So now we're going to do something called a proof. And what a proof means is they're going to tell us what to prove. And what they say is prove that angle 2 is congruent to angle 7. And so they're going to start you off with information, and they tell you the given. They have to tell you stuff in order to prove stuff. So your first step in a proof is to go and copy the given. So you're going to say L, and I'll just spell it out. Line L and M are parallel. Okay, they tell us that. What's my justification for that? How do I know that? That's given. Okay, so that's our first step. Start off with what you're given. So I know that L is parallel to M. So what that means is that I know this line and I know that this line and this line are parallel. Why? Because they told us that. And what they're wanting me to prove, they want me to prove that angle 2 is congruent to angle 7. So what I could do from there is I could say that angle 2, and I'm going to use the less than sign, even though it's not really, it's not supposed to be a less than sign, but imagine that's the angle symbol. I'd say that angle 2, and I don't know how to type that in, so I'm going to say angle 2 is congruent to angle 7. How do I know that? Well, if you have two lines, two parallel lines, cut by a transversal, we know that 7 and 2 are the same. Why? Because they are alternate exterior angles. So I could say why? By the alternate exterior angles theorem. So I started off with what was given. I immediately jumped to what they wanted me to prove. Why is 2 equal to 7? Because we know by the alternate exterior angles theorem, if you have two lines and you know they're parallel and they're cut by a transversal, then we know that alternate exterior angles are congruent. So that's how I was able to jump straight to the conclusion. Most times in proofs, we're going to have stuff in the middle. But this would be the equivalent in English class where you have an introduction and a conclusion without a body. Usually there is a body. All right, for here, they want us to prove the same side exterior angles theorem. And so they tell us that L is parallel to M. And they tell us that 1 and 7, or they want us to prove that 1 and 7 are supplementary. So what I'm going to do is I'm going to start off with my given. I know that line L and M are parallel. You don't have to actually type out all the words. I'm just typing them out because I don't know how to type the symbol into this program. How do I know that? That's the given. That's what they tell me. They give me that information. So what that means is that these are my parallel lines. Those are parallel. They tell me that those are parallel. So there's special relationships. And technically I could then say that 1 plus 7, I could technically do this. I could jump to the conclusion and say that angle 1 plus angle 7 is equal to 180. Why? Because 1 and 7 are same side. Well, we don't have that theorem up on the board, so we're not going to jump that far. But there is a theorem that says we could jump there, and it's called the same side exterior angles theorem, but we're going to actually jump, we're not going to use that theorem as part of our proof. So what we're going to do, they want us to prove that angle 1 and 7 are supplementary. So we're going to start with like angle 1. And we're going to make a plan to get to angle 7. I think this is my plan, and there's many different plans you could pick. I am going to go from 1 to 5 first, because I know those are corresponding. And please ignore my freestyle handwriting. Those are corresponding. And then I'm going to go to 5 to 7. I know those are supplementary. So that's my plan. I'm going to go 1 to 5, say they're corresponding, go to 5 to 7, and then somehow connect 1 to 7. And you're going to see that. So my second conclusion is that angle 1 is congruent, and again, I don't have the congruent button, so imagine there's a little squiggly on the top. Angle 1 is congruent to angle 5. How do I know that 1 and 5 are the same? Well, that is corresponding angles postulate. The corresponding angles postulate says if you have two parallel lines cut by a transversal, then the corresponding angles are congruent. So 1 and 5 are congruent. So now I'm at angle 5. How do I go from 5 to 7? Well, I could say that angle 5 plus angle 7 equals 180. 5 plus 7 is 180. How do I know that? That is the definition of being a linear pair. So 5 plus 7 is 180. Okay. So now what I'm going to do, I know that 1 equals 5. I know that 5 plus 7 is 180. But what I'm going to do, instead of putting a 5, I'm going to put a 1. So I'm going to say that angle 1 plus angle 7 is 180. How did I do that? Well, if I know 5 plus 7 is 180, but I know 5 is really equal to 1, I can use a property called the substitution property. So I have proven what they wanted, so I could say angle 1 plus angle 7 are supplementary. How do I know that? There's many different ways to write this, but adding to 180 is another way to say supplementary, right? We'll just say so there's my proof. Okay, on this proof, they tell us that angle 1 is congruent to angle 2. They tell us that angle 1 is congruent to angle 4. And they want me to prove that these lines are parallel. To prove a line is parallel, you're going to use the converse. And the converse says to show that two lines are parallel, you could use any of those theorems and postulates. For example, if I say that 2 equals 4, if I know those are equal, then by definition these have to be parallel by the corresponding angles postulate, the converse. So it's like the backwards. So let's start off with the first given. I'm going to say angle 1 is congruent to angle 2. And again, you would actually write it like this, but I don't have that software. So justification, that's the given. That's what they tell us. Now you could, this is like writing an essay for English class. There's multiple formats, multiple ways. You could go ahead and list all the givens at once. Most people list what you need as you go. So I know 1 equals 2. So I know by that 1 and 2 are the same. And I'm trying to get, I also know, let's see, what else can I do? So far, I'm going from 1 to 2 by the given. That's what they tell me. 1 equals 2. Now, I can't go from 2 to 4. I can't go to 2 to 4 because they didn't tell me that these lines are parallel. They have to tell me that information. So I can't just say 2 equals 4 because they did not tell me those are parallel. But I could go from 2 to 3 because that's the definition of vertical angles. So now I could say that angle 2 is congruent to angle 3. How do I know that? And I have the theorems up on the board over there. That's by the vertical angles theorem. And vertical angles theorem says if two angles are vertical angles, then they have equal measures. Alright, so I also know that 1 equals 4. Okay? So I know 1 is 4. So what I could do, I'm going to put that down actually, that 1 and 4 are the same by the given. So I'd say angle 1 is congruent to angle 4. How do I know that? By the given. So far, I know that angle 1 equals angle 2. I know that angle 1 equals angle 4. And so, if angle 1 equals angle 2, and angle 1 equals angle 4, well, what I could do is I could use the substitution property, and I could substitute 4 in for angle 1. So I could make the conclusion that angle 4 is equal to angle 2 by the substitution property. So if I know 1 is 4 and 1 is 2, then 2 is also equal to 4. Okay? So I just showed that 2 and 4 are the same. So now I could jump here and I could say that line L and line M, this should be an L, are parallel. How do I know that? The corresponding angles postulate, the converse of it, says that if you could show that 2 equals 4, if you could show that this measure equals this measure, then that's enough to show that the lines are parallel. So if 2 equals 4, then we know that those are parallel by the converse. So converse means like the opposite is true. Well, not exactly, but pretty much. So I just proved by using this information that L and M are parallel. Now looking at my proof, and this is going to happen just like in English class, you may have stuff you don't really need. And I proved that 2 equals 3. That's good to know, but that would be something we don't need for our proof. So I'm actually going to go back and say, you know what, that didn't really help us any. So I'm just going to go and delete it. Like, yes, 2 equals 3, that's true, but we didn't really need that. So now we started off with our given. We had another given. I could have listed them under the same given. And then I said that 2 equals 4 because I substituted 4 in for angle 1. And I got angle 4 is equal to angle 2. And because those are equal, that means that they are parallel by the converse. Of course, by